Hey, hey, what's going on? All right, so I took some, but hey, Brian, what's up? Yeah, it's in the AM for sure. Uh, I'm not still up. I just got up. I'm like, hey, man, I'm gonna do some stuff today. Oh no. So I got it going in a series circuit now, like a 100% series circuit. The 10 strands of 20 gauge are now all linked together, but they have a high voltage diode in between each previous circuit. So it's still kind of separate. And the amp draw went like it floored, man. It literally went all the way down to like 100 milliamps or less at the 5 that I normally do, the 5 volts. It's awesome. Hey, hey. So hooking it up in series and having the high voltage diodes between each of the previous circuits, which were, let me see, 3 strands and 3 strands. So that's 30, not 30, but each strand is 16 feet long. So 348, no, 6, something like that. Feet for the first two, and then like 70 feet for the third one. But now they're all linked together, but they can't oscillate completely. They only oscillate in their individual circuit connections, because there's 10 strands and there's only 2 diodes in there. So there's got to be some kind of oscillation going on somewhere. Um, this is this is pretty good. I mean, this is 5 volts. I mean, really, what happened is I got bored. I was just chilling, and this is only like a, somewhat of the coil here. Its potential, because I got a 32 gauge strand that I wrapped with the 20 gauge strand, and there's now 10 strands of 32 gauge in here as well, same length as the 20. I was thinking about setting those up as like a generator or a pickup, and just having it all be right there. um, I think this is great though. So the advice that I got from Double O and Mike does, thumbs up on that, because the amp draw is just so much more reasonable than it was. It's really, and I just don't, even if it does, the switch does get caught, it only pulls 1.2 amps. And that's good, man. That's awesome. That means all you got to do is flick it once or twice and it'll work again. And resetting often helps. Like if it's stuck, you just turn it off. And when you turn it back on, typically it won't be stuck, at least not immediately anymore. But here, we're going to turn it up a little bit because we can now without it like jumping up to like 5 amps and stuff. we're at 0.3 and we're all the way up to like 8 volts. And then as the speed increases with the voltage, the amp draw will go down even more because but I don't think it'll run at 9 volts for very long. I don't know why that is right now, but I have a feeling like the switch will get stuck. And then because the reed switch is so far out, the amp draw is less as well. It's a very small range for it to work well. You get it in too close, it just perma is on, and if you back it out too far, it doesn't work at all. If it's up too high, it's really like a very small range on a three-dimensional level. But having that light on the reed switch helps out a lot. I mean, it helps out tremendously when you're just, your voltage is low enough so that you don't get your ionization in the reed switch. Um, this light will go on and it will tell you whether or not it's working. I think that's awesome. I think having this little toggle board here is awesome. So I can turn it up to 12 and virtually it won't go on until I hit the switch. And it'll go immediately to 12. So it is kind of like having a capacitor with a switch. I mean, it is in a sense. I just like how much more gracefully the 6 magnets move than the 3. That's why I put 3 more in there. Didn't have anything to do with making it run by itself. It'll run by itself either way because of the way where I put everything. It'll work. Uh, it works better with the 3 transistors. I'm just saying. I got to turn it up to like 7 volts to get it to jump with the single circuit. Because it did have a lot to do with the current. It did. But I can still make it work. I just did. Hi, hi. What's up, Sean? What's a tweaking table? I have no idea what that means. Okay. So, good morning, everybody. Early. How we doing? This is Pulse Motor Mayhem. That's what we do here. We do pulse motors. We do different kinds of pulse motors. This right here is an axial flux, run on a reed switch and a transistor. So the reed switch pulses as a transistor with the magnets, so it's timed with the magnetism. It's not necessarily timed with any coil or whatever, it's timed with the switch here. And because, yeah, I don't know, I can't guarantee that this one will, the way it is built, start every time. I could with the 3 transistors. We'll see what happens. See, when that stops moving, it should line up with the reed switch. At least one of the magnets should line up with the reed switch. So I'm priming it for 9. We'll see what happens. Bam! I love it when it works. It's like, woo! And it's so simple. There's nothing complicated about it. I mean, and it's so satisfying. It's like, ha ha. Yes. Not like this kind of ha ha, but like, yes. Good morning, everybody. Welcome to the channel. Appreciate you stopping in this morning. It is about 6:30, I think, right now, where I'm at, anyway. We're looking at an axial flux design here. Pretty much a self-starter. Because of the way I have it built and where I have everything positioned, this thing pretty much, except for just one time earlier, starts itself when I turn it on every time. I feel pretty kind of, like good about that. It's not a big deal though. It's really not. It's so easy that it's just not a big deal. Just look at where everything is lined up right now, right? You got to prime it though. You can't like use a knob and turn it up, I don't think. I mean, maybe I could. I never tried. But we'll turn it up to 9 and we'll prime it. It's primed to 9 volts. Turn it on. Oh, it didn't work. Oh, that's because it's the switch is stuck. Let's see if it's still stuck. Nope, but it's in the wrong spot now. There we go. Oh, see, man, it's a switch for sure. So maybe when it's working at like 100% efficiency, the switch, it won't be so sensitive as to where it goes. I could switch that out. I'm going to switch this out, but I'm still only drawing like 0.1 amps. Oh, that's not good. All right. So this, nope. It's a telltale sign, man. Every time I try and show people what's going on here, it breaks down. But we'll switch this out. We'll get it going. I don't know how long for, though. And it's weird because this one still works. It just doesn't work very well. Kind of like some transistors I know about. Got a whole bag of those things that like kind of work. And I got to get my screwdriver out and remove all this extra connection. So again, thanks for coming. You're free to watch me tackle this if you want. I personally think it's a good idea. Yeah, that's not hot at all. That's awesome, man. I just things have been kind of burning up on me a little bit every now and then. So we'll put it at 5 this time just to see what the switch is on, doing about whatever. So that's the spot right there. And what's our amp draw? Nothing. 0.1 to nothing. So less than 100 milliamps. See what happens when I flatten this out. See, I mean, this light kind of gives a accurate depiction of the intensity and the reach of the magnetic field of these cube magnets. It's going to put a little tiny drop on here. Yeah, I want it to be in this really kind of a specific spot. I'll line up in the front here. And it really doesn't matter because it's just the coil can move, so none of that matters. It's just where the coil is right now, that's where the reed switch should be. to get a jump start. That's what I'm trying to get at. This thing will move forever. So, I mean, if we need it to be perfectly still, which we do, to demonstrate that, it's going to take a minute. Do I need to demonstrate it? I mean, it's perfectly logical why it happens. And instead of the magnet moving into the range of the switch, it just starts there, and voila. Pretty easy. Straight across, man. It just works. When you're using a reed switch, of course. Maybe even a Hall effect sensor. I'm not sure, though. Never really got that many Hall effect sensors to work, function the way they're supposed to. Nine volts. Yeah, something's not right. I think the elevation is off by just a little bit. All right, here we go. Good morning. Good morning, people. How we doing? Papa Bale. Welcome to the channel. Oh no, I never turned it off, so this isn't good. There we go. I think that is working better already, just being a little bit higher, a little bit more stable. It looks to be a really good spot. I just feel like it doesn't have to be that close. Okay, let's try and get, because this is a lot of weight right here for that thing to just be holding on to. So let's And lessen that burden a little bit. But it is a wire. There we go. So I don't know. Do I think it's the best? Like the fastest design? No, not at all. Matter of fact, I heard that when you twist the wires, you develop an antiphase with your phases. And I never knew if that was a good thing or not, and whether I wanted to do that or not. But I don't know. We'll see. This is just the beginning. I've only made 2 kind of Litz wire type coils so far. I can feel some heat on that, but it's not that bad at all. Like it's not bad at all. And this thing operates as a fan as well once it gets going at a certain RPM. So that's good. As long as there's no fire, that's a good thing. Wow, this is not right. What's going on? Let's see. You can definitely see it when it's in the right spot. It'll have some push to it. Wow. I just never knew that the struggle was so much, man. It wasn't like that. I plugged it in and it went. And that's the words that were written. I plugged it in and it went. Mm. At least, I would say about 70% of the time, that's how it works out. All you got to do is like follow the basic principles, and then 70% of the time it'll work. The basic principle is flow, direction, and current, voltage and current. And its path. You got to make a path for it to flow on. So the flow and the current, right? The voltage or the wattage. We'll call it the wattage because it is about voltage and current and how they interact with one another and how you know, like a yin yang type of thing. Can't have one without the other, um, and have it work or function. It doesn't have to be a lot of the other. It's got to be something. Uh, yeah. So you need your wattage, and you need your flow. You need your pathway. You need your path of least resistance that everything's going to function on. And that's where this breadboard comes into play. I mean, it's so once you understand how to build a breadboard, I don't, you know, it's pretty simple. You know, you got your two ends of your reed switch. The blue end is going to go into your base. You got to find out what your base, your collector, and your emitter are if you're working with an NPN, or you got to find out your gate, your source, and your drain. You're working with a MOSFET. So this reed switch goes into the base to trigger the base, right? And the other end goes into the collector to get the voltage it needs to work, the base, okay? Because that's where the base is going to get its punch from. And that's why you put the resistor on there, because you don't want the entire allotment of what's going into the collector, which is currently 7.3 and 0.4 amps is going into the collector. If I didn't have a resistor there, all that would go into the base. Not like the base can't handle it, but it's a lot. You don't need that much. So you put a resistor in there and it lessens the burden on the base. Okay, so now we have the power going into the collector. We have the other end of the base going into the collector, or the other end of the reed switch going into the collector. One goes into the base, the other end of the reed switch goes into the collector. And then the emitter is tied to the coil, and the coil is grounded. Voila. And this is what you get from doing that. Everything else in the middle here is an experiment. You know, the coil is an experiment. Basically running the transistor with the reed switch for me is an experiment. You know, it's not what I normally do. Normally I do a trigger switch or a Hall effect, you know, something that's supposed to work with the transistor. This reed switch will run all this stuff without the transistor. Yeah, you can like directly connect the reed switch, the power supply to the reed switch to the coil, and the coil to the ground, and it'll work just like that. It won't be as good, I don't think, but it'll work because it's working. Now, previously, I had this coil split into 3 different connections with 3 different transistors. And, you know, each one had its own switch on the board over here. And, but the amp draw on that was sick, man. I mean, literally when you turn them all on, you're drawing well over an amp. And when you just had the 1 and the 2 on, you're drawing like 3 amps. Because it's literally just like 30 feet of 20 gauge. And that's too many amp, man. That's too many amps. Right now we're at 0.3. Now we're at 9.5 volts. Oh, nope, there it goes. Switch is stuck. It's too many volts, man. 9 is too many. And that sucks because I want to do like a 9-volt system, but 9 just. Got 8.1 and we're at 0.5 amps. But when we go from 0.5 to 1.4, something isn't right. And I do believe it's how I have it hooked into the collector, the reed switch, how that's all together. You know, it's the same virtually as having it by itself, because you're putting virtually the same amount of electricity through it. Uh, uh, so when I turn it up to 9, it gets stuck in its closed phase, and it's like perma stuck, which means it's not, it's not pulsing when the magnets pass by. It's just closed. Irritating thing about a reed switch. And I had these big ones, but that's not going to function. I mean, literally, for it to work right, it would have to go underneath, and maybe I could get some of those later on, like a lot later on. This is it, though, man. This is the last hurrah. Kind of got to start. Well, it's not like I'm never going to do this. That I would just, but I got to start, working. Got to get back in the job force. And that'll be good for me. Get a freaking job. So 7.5 and 0.4, 0.4 amps, 0.3 amps. So it's still in a fluctuating situation. I say that's pretty good. I mean, it is just one coil of 160 feet altogether of 20 gauge. But the way it's connected is you have one oscillating system, and then you have it go through an HV rectifier diode to the next one where it can oscillate, and it goes through another diode where it can oscillate, and it ends in oscillation. I don't have a diode on the end, but yeah, each one of these, like this, there's a connection here which has 3 strands in it, and another one that mirrors it, and then there's one on the end that has an additional strand in it. So they're not all the same. And I don't think they really have to be. I mean, the gauge doesn't even have to be the same. I mean, honestly, I've built some crazy stuff. I mean, for it to work the best, you should probably use the same gauge um, throughout your entire drive. But, like up there on the wall over there, I got the amp funnel, and every coil in the amp funnel is a different gauge and a different size, like a different length. Every coil over there is different, and it runs at like 1,500 RPMs. So you can't say it doesn't work, but you can say it could probably work better, which you probably could say. So I do want to emphasize that apparently it gets hot. That's not hot. Is this hot? There's no heat, really. Running pretty good. I mean, the tape does feel a little like more moist, but it's not hot. I call it long duration of warmth that made that happen. uh, so let's take this out of here for right now. All right, so as you can see, it's coreless right now, or air core. Maybe you can't see. There it is, air core. Put this core in there. Boom, soft iron core. I don't think we need a soft iron core though. I think that will make my situation worse. That's my hypothesis. But I'm curious. I'm curious as to what will happen running that with a soft iron core in it. Um, yeah, the small wires will draw less current, but the small wires will always have less potential than the big ones. And maybe not. Maybe not. I know they're going to get hot faster. Mm. They can't handle the heat. They'll disintegrate, kind of. All right, what am I going for? I think I'm going for water. Be good to get some water in me real now. But yeah, one thing that I really want to do is hook up the 32 gauge strand that's in this coil. See, there's a 32 gauge strand in here too. It goes with the 20. I want to conserve these because they are nice, lengthy pieces of wire that are currently straight, unkinked, basically. Useful. Oh, and I had those ones backwards. I guess it's okay because I think all these negatives are actually hooked together. So, but just taking that apart revealed that it wasn't put together, quote unquote, the right way. This is the appropriate one. Okay, that's good. And then the thing with these wires is that there's an end where you start, and that's an additional wire in your bunch that won't lead anywhere. So as soon as you find that one, it's good to get rid of it. See, so there it goes. You got your 10 ends right here, and then your 10 ends over here. Now I'll have to go through all those and connect them. Not so sure I'm going to do that like right now with people watching and stuff, but it's really easy to do, actually. It's just tedious. It's the only problem with it. I mean, if you got your stabilization stuff going on and you like tedious, this is your thing, man. You need to do this. This will set you free. Oh, that's going to be great, I think. And then whatever I do with that electricity that's generated from the 32 gauge, don't know. I could charge something like a cap or but if I'm going to generate electricity, I definitely need one of these in there. One of the soft iron cores needs to be in there. And then I believe every aspect of that coil in regards to generating electricity will increase, like the amount of amps, the amount of, specifically the amount of amps that are being generated. And it's more than likely going to be less than I want to say less than 100 milliamps, even with the core. 32 gauge was never really good at generating amps. It might go, 0.25, 250 milliamps. And in order to the bare minimum to run something other than a light, I would say is like 300 milliamps. Heck yeah. Gotta get the meter in there. I got to use a meter to hook it up anyway, so need to get a new 9 volt. I think it's a 9 volt. That's actually, I'm going to see what kind of batteries, the meter that I will be using to connect that 32 gauge cable up with. Size of the battery. Because it needs a new one for sure. Morning, everybody. What's up? What's up? Let's look. Dang, it didn't look good enough. Okay. Triple A's. Dang it. Dang it. Those are the ones I do not have right now. But this meter is actually really, really good. So I'm going to go get some triple A's. And it's lasted umpteen times longer than anything I could ever plug in. It's just fabulous. So, I mean, I would say there definitely is some truth that in that the older equipment, the older stuff, like TVs and stuff like that, have better stuff in it, like transistors and stuff like that. Um, this older meter runs solely on batteries, my AAA batteries. It functions, even though it's dying right now, better than most of the ones I can plug in with a USB. It's older, it's built better. It's got better stuff in it. That's why I'm not going to like, hopefully it never stops working, you know? Mm. So I'm going to see. Yeah, 0.1 amps being drawn right now, between 0.1 and 0.2. So judging from that, based on what it was before I changed it into a single series circuit like this, um, it's a lot better. I mean, it's at least an amp less proportionally. So at 6 volts, it's an amp less. At 9 volts, if it could run at 9 volts, it would be like 3 amps less. That's what I mean. I mean, it would be just less amp draw all around. Especially when it gets stuck, because when it got stuck the last time, it went up to like 10 amps with all 3 of these on here. The 3 transistors, it went up to 10. When it happens with the 1 transistor and it being all in series like this, it went up to 1.4, which is a lot safer. And I think that's a good position for the coil. See, every time I take the coil out, I got to put it back in its position, and I don't have it marked. It's just pretty close. These are stationary. These are glued down. These right here. So I use these as kind of like a marker. Heck yeah, it's definitely going faster. Yeah, see, like if anything gets out of position, and that's why it's logical, because there's only one logical answer. If you move anything out of position at any time, it won't work. But, you know, if you put it where it goes logically, it'll work every time. And I think the 6 magnets always moved a little bit slower than the 3. Because there's no coast. There's no coast with 6. It's like boom, 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 boom. With 3, it's like boom, boom, boom. You know, doesn't matter how fast it goes. That's the pattern. There will always be a coast in between each pulse with the 3 magnets. Always, because it's proportionate. Doesn't matter how fast it goes. Even if it's on top of itself, the pattern won't change. uh, and I could see where you think, and it might get distorted as to whether it's changing or not, but I guarantee you do the same thing with 3 that you do with 6, and you'll see that the pattern doesn't change. I mean, speed it up to the point where it's right on top of itself, or it's, you know, like merrily, 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 you know, it's doing that kind of thing. Um, you do that with 6, and you'll see that it's the pattern doesn't change. It doesn't change. So we're at like 6.9 volts in, 6.7, 0.1 amps. Um, Running a single coil drive here. We got a reed switch for the pulse. We've got a transistor MPN for the switching, or aid and switch. So what's happening is the reed switch is pulsing the transistor at the pace that it's spinning at. So it's using the magnets. There's lots of ways to do this. I could, excuse me, I'm going to hook all these 32 gauge strands together, and then I could use it as a trigger coil very, very easily, I'm pretty sure, which would function the same as a reed switch pretty much. I don't think, since I'm not doing a counter rotation with this, I don't need a reed switch necessarily. So we'll see what happens. And I think that the counter rotator would work with the trigger coil if I had tested it with 24 volts instead of 12. So I want to amend what I said earlier about, a trigger coil not being able to counter rotate. I think it'll work. It just needs more power. But I'm not sure, though. It didn't work when I tried it, and I developed a hypothesis as to why. And it was basically because you can spin a trigger coil rotor either way. There's no definite direction. It goes both ways. And if your rotor goes both ways, how can you kind of rotate? That was my logic. But I don't think that's right. It's probably not right. Because of the forces, they got to push off of each other. You know? It was very discouraging for me not to have the trigger coil work, so I'm probably just scratching my mind for ways to make it work. But as of right now, trigger coil doesn't work for a counter rotator, for me anyway. But this is not a counter rotator. This is a axial flux. I believe that all the magnets are facing north, facing up, so south is facing down. South is facing the coil in this regard. So the coil is interacting with the south, not the north. Yeah, the reed switch is plugged into the collector in the base of the transistor. So it uses the energy it gets from the collector to trigger the base. I believe it lets, I don't know exactly know how it works, and it's kind of freaking me out now. Because if it lets the full allotment of energy from the collector go to the base, that's pretty much not good. Because, I mean, even a MOSFET only needs like 5 volts to run. Okay, so, I mean, if I'm turning it up to 12 volts and that sends that to the base of an MPN, I mean, that right there is not good. But it works. This works. Haven't had too many problems with it. I have like a primer is what I want to call it. So we turn it up to, what we want to run it on, 6 volts, and we turn it on. I cheated. And seriously, like waiting for this thing to stop entirely is kind of a drag. Yeah, I mean, right, sure, whatever you say. Friction on the pole, I got it. Isn't that the way it's supposed to work? Okay. If your pole doesn't spin, if your pole does not spin, you're going to get friction on your pole. Okay, if your pole does not spin, you're going to get friction on the pole. Can I break it with a capacitor and a diode? I do not know how to do that, Nathan. Are you talking about the counter rotator? I wish I could. Oh, man, let me show you what I got. What's going on here? Every time I like get a new spot to put the circuitry, right? A new breadboard or whatever, it always ends up frying. It always ends up melting somehow or not functioning right anymore after a certain period of time. Don't know if it's like a designated period of time or what, but what I had going on with this thing ceased to function because every time I would put the 20 gauge into the breadboard, I would see sparks, which was weird. I thought it was all weird because it was just working a second ago, like I just did a live stream about it. But yeah, the breadboards obviously aren't designed to handle what I'm doing to them. But that sounds interesting. Sounds really interesting, actually. So, like a diode and a capacitor, right? So you have the energy flow into the cap, and then you take the diode and you reverse that. Now, I think it goes back into the cap. So you get energy going in the opposite direction. That's a great idea, actually. But that's got to be a pretty big capacitor to deal with the momentum. Or is it like a pump break and it happens, many times in a row? I see what you're saying. So the capacitor that I was planning on using with the counter rotator flying around here somewhere. It's a little tiny 50 volt, 2.7 UF microfarad. Little shocker, there it is. This is an axial flux pulse motor tabletop toy. That little bad boy will shock you. But it won't hurt you. That's what I'm saying. It'll just shock you. There are some caps out there that'll mess with you. Take it all from you. Wow, my phone just kind of reset itself. I apologize. There we go. Oh, I had the remote for the TV in my hand. That's what happened. All right. Well, oh well. Turn that off, I guess. So I won't be able to read comments right now. I don't. I must have hit a button while it was in my pocket. Yeah. So I mean, there's I'm hearing about like capacitors, like starting things and stopping things. I think that's cool. I really do. Maybe I can figure out how to make that work, but you know, it's mm. But you know, if I need a certain voltage of capacitor that's obscene, then I'm not interested. If I can do it with that little 50, this one right here, I can do it with this. That's a sound plan. Heck yeah. It'd be great to put a brake on it, especially the counter rotator, man. That one is really hard to stop. Oh yeah, I've never used a soldering gun in my life, man. I have. There's so much stuff. If anything got reverse engineered into doing this, it was me. But it's just so like beautiful how easy it is. How simple it is. You just have to take your time and do it in steps and make sure that each step is done correctly to the end result. So each step that you take has got to fit into the grand design of the whole thing, or you know, just keep doing it over and over and over again until it does. You know, that's virtually where you're at then, I guess. What's the purpose, though? I guess the purpose is to make me feel good. It's easy to do. I can do it. I did it. I'm doing it. No, I'm not saying it's all easy. I'm not saying it's all, but I mean, if you follow the basic principles of how it works, basically it's pretty easy. There's like some advanced stuff that, breaks all the rules, man. It literally does. And you're never going to get there following stuff like this. It just isn't going to happen because the way that it's hooked up just counterintuitively doesn't make any sense, but it works. It works. Either that or people have been lying to me. One of the two. That's okay, man. Whatever. I don't do it myself. I don't lie to people. So, I mean, if you calling me a liar, I take that personally. I never lied in my life, pretty much, for any reason. I mean, if you want to call ignorance lying, and you can totally do that, and then any person that opens their mouth to give their opinion is a liar. We all know that's not true, right? I think what people have to say is very valuable as long as you're not slandering people or lying about them. Wink, wink. That's the same thing. Okay. I open my mouth to share what I've done and how it works, and that's that. If anybody's interested in like doing this stuff, it's really kind of simple. You need an NPN transistor. That's how I work with it, or a MOSFET. You need some sort of switching device that manages the switching of the pulse, which is generated from the base of the transistor. You can either hook a reed switch, you can hook a Hall effect sensor, you can hook a trigger coil up to the base. And basically what it does is it triggers and it keeps time. So it's what the base does. And then the emitter. So when the base is timed or triggered, it will connect the collector and the emitter, and that will close the circuit. When the circuit's closed, it'll ground. At least that's what it's supposed to do. That's the basic concept. From emitter either through the coil to ground or emitter to ground. Either way, you go from emitter to quote unquote the ground. So that's how that works. And in order to trigger the base, you need an electrical charge or a current or some sort of voltage that will connect the collector and the emitter, closing the circuit. And this is supposed to switch, so it's supposed to close and then open when the current dissipates. Or in this case, when the switch opens and closes, the base will open and close. And the only reason it currently is working is because one end is plugged into the collector pin. One end of the reed switch is plugged into the collector pin, which will filter it through the base. That's why 5 volts works so well, because, you know, So I get that. Uh, there's like small problem with the cap thing though. I mean, I don't see any of this right here being able to charge a cap of any size in a relatively fast fashion. I might just not know what I'm doing, and that's totally 100% true, especially when it comes to capacitors. No idea how to hook this up. Um, so diode, we'll use a 14007 diode in the 50-volt capacitor. See, I mean, and that's the amount of information that was given to me right there. I don't know. I guess you're trying to test me or something. All right, I'm going to put henceforth right now that I have absolutely no idea what I'm doing right now. And we're going to go for it. I don't know. And honestly, I think without solder, I'm going to have to use the breadboard here. And I can kind of see how it works. I don't see where the cap is getting its energy from. And I do want to have any kind of brake system hooked up to the switchboard over here. It's got to be hooked up to the switchboard, or I got to be able to turn it on and off. So man, I can't like wrap my head around how to put these together to make that work. Well, that's not entirely true. I don't know where to place these. Kind of understand the concept though. All right, so I will put so it's going to dump out of the cap to the diode, directionally going that way. All right, so if a charge goes into the cap, it will be dumped into the diode and shot in that direction. That direction, however, has got to be the opposite of the way it's going. This is where I get confused. And wait a minute, if it's a DC cap, you got to put it on the other side so that it's DC going in to the cap. Me, I don't know. Maybe I put one on both sides of the cap. But I don't think you need to, because I think that cap is already a DC. That's why we need to have it be DC. All right. So yeah, this is, I mean, what do we do now? We put voltage directly into this. That's one thing I was thinking. And that way I could use one of my nice long 20 gauge connectors and just plug it into the switchboard right here. Boom. But then where does the other end go? To the emitter? Will it go to the emitter? I wish I had my TV on right now, and I'm probably not really talking to anybody who knows what I'm talking about anymore, but maybe I am. I don't know. We're gonna do this. So yeah, because I only want it to be on when I want it to turn off. Man, I probably need to hook up my 32 gauge is what I'm thinking. But because of the diode, I'm thinking that we obviously are collecting this energy from a coil. So this won't be connected to the power supply. Maybe we could connect the end. See, we have one end going into the ground, right? Maybe we can stick 2 wires in here. Because that makes sense to me. We come, yeah, through the coil. Huh. Huh. I used to have these just simple switches like these, but with a red and a black. I need to get more of those because this is good, but it defeats the purpose. This is going to be on all the time, and that's not what I'm looking for. So in this case, I believe we're not just using the rectifier aspect of the diode, but the directional aspect. But I mean, it doesn't make any sense. Because the cap is going to send it in one direction. Unless, okay, so this is where I probably shouldn't be touching this without gloves on. mm. This is how I saw it in my head first when you first mentioned it. No. Okay, so now it'll go into the cap, go out the cap, into the diode, back into the cap, right? That's what it's supposed to do, I think. But it's not, now it's not connected to anything that's going to stop it. Huh. But I see how that, just cycling the energy back into the cap over and over again. I don't know. But that's what that would do. Yeah, see, this is where I say basic and then advanced, because if you switch this diode around, you are now putting positive into negative, right? And it's not like a series, it's like a backup. It's not like a path of most resistance. It's like a, then you're doing this. Okay, and that, I don't know. Is that what we're supposed to be doing here? Because you said break. So is this what we're supposed to be doing? I, I'm just asking because I have literally no idea what I'm doing with this. But I'll figure it out. I mean, I could look it up, I guess. Something to do. To use a I'll just ask chat. I could ask chat. How do you use a capacitor and a diode to slow down a pulse motor? Easy enough. Yeah, that would be awesome to have a break, but it's got to tie into some sort of on-off toggle, a pedal of some kind. Is this the end of the road? Oh, no, I'm probably going to build a lot more coils. This is just an experiment. I do want to hook the 32 gauge up. That's going to take a good 3 hours to set that up, though, man. I mean, my fingers are like raw, and that is a very small gauge. So just getting the wires into my fingers is going to be a fun task. Yeah. So that's one thing I'm going to look up, is how to break a pulse motor with a capacitor and a diode. And have it have its own toggle, like turn it on, turn it off kind of thing. Yeah, Mike stopped by a few days ago and said that I should do that too. Use the cap to start it, not just to start it, but you're saying I can use it to stop it as well. He said start it, you said stop it. Mm-hmm. Right now, I am a bit of a crybaby working with caps, man. It'll pass, I'm pretty sure. But, you know, I'm like, hell no, we're not going to do that. Not right now. This thing just blew up in my face. Literally, I had to like put my hand on my face to make sure it was still there. You got to be really careful when you're messing with these things, especially when they're loaded. It's not a joke, man. It's no joke. Got to play it safe. But I figured 50 volts, 2.7 microcapacitance, I can work with that. That thing will pop 50 volts nonstop. Hello, what's up, everybody? Thank you for stopping in. This is Papa Bale, and this is Pulse Motor Mayhem. All right. So what we're working with currently is a reed switch pulsed axial flux pulse motor. This is not a counter rotator. This is just an axial flux with 6 cubes, pulsed by a reed switch, run on an M.P.H transistor. And it's powered by a DC power supply. There's currently 5.55 volts going in, less than 100 milliamps. So, and my curiosity is piqued. We're gonna find out how to stop our pulse motors with a cap and a diode. I think that's intriguing. I mean, I literally don't know how to do that, but I'm gonna find out. Yeah, I hooked it up 1,000 different ways over here on the other side of the breadboard just to get a better perspective of what I was looking at. Yeah, I can see some ways that it could be and some ways that it can't. There's just, and then it's probably going to end up being one of those ways that I can't hook it up that it needs to be hooked up in. So, you know, I'm gonna ask around. I'm gonna see what's up, and then we'll do one to start and one to stop, if that's doable. I apologize for anybody trying to chat with me at the moment. I can't see anything about what's going on with that. All right, we're good. That's cool. At least it looks good. Can't really tell what's going on right now. Ever since I disconnected from multi-view, it's been acting a little strange. I hope everything's okay. And that's okay. It's still early in the morning, so I'm not expecting too many people to have an abundance of things they want to talk about right now. Um, so another thing that I can do is I can change to 6 into 4. I think the 4 is ultimately going to be the best. So I'm going to switch these out real quick. stay with you. Mm. Get it. And the north side of these is definitely facing upwards. All right, and we are good. Sweet. That didn't take any time at all. Now there's definitely some pause in there, coast. This will eventually end up going faster than the 6. And I believe because of the spacing, it will go faster than the 3 as well. And it's because of the exact reason you're thinking that it's not going to do that. It's because of that coastal moment. It's because there's a moment in there where there's, more space between the magnets for it to coast. Now, you see what you see, all the optics that you see are different because of the spacing as well. So like when 6 was a solid, almost like a solid ring of silver going around here, that's just because there was less space between the magnets. All right, so in order to draw 100 milliamps, I had to turn it up to 7.1 with the 4 magnets. This is 9.5 volts, 0.2 amps. And that's the other reason why it'll go faster, is because of that break point. Yeah, I can turn it up higher. I know that sounds cheesy, but I can turn it up probably all the way, and it won't even draw as many amps now as it did at this point, the other setup. And that's just taking 2 magnets out of here. The magnets, I mean, it was running smoothly and everything, but the magnets were too close together for it to really stretch its legs at all. And I mean, if your bearings are good, coasting is the best thing for your efficiency, for everything. You need to have that coastal phase where it's just moving on the forces of nature. You need to combine all that with whatever it is you're doing with your pulse motor. Combine all that, and you got something better than if you don't. And I mean, the nature stuff is going to be there whether you want it to be or not, if you space your magnets properly. I say 90 degrees is great Great spacing. Say 120 is good spacing. I think 90 is better than 120, but 120 is good. We could check 120 next if you guys want to. So we're at 10 volts now, 0.2 amps, 0.3 amps. 12 volt system coming up. $12 volts, 0.4 amps. $444. Well, close. About 440. Probably stop at about 444 with 4 magnets. That's awesome. The limitation is in the coil. It's only 160 feet of wire. Okay, there's nothing potential about it, really. It is twisted. It is 20 gauge. So it'll move the thing, but there's no like hidden specialist. There's nothing there. It's 160 feet. And it's like one of the smallest coils that I've wrapped. Literally, it's like 25 turns. But I think for what it is, it's doing a great job. There it is. It was at 444.8. So neat. I think it's awesome. The fact that I actually get to turn it up now is freaking awesome. So I'm going to stick with 4 magnets for right now. It's kind of dusty in here. I'm going to have to dust. Oh, wow. That isn't dust. That's graphite powder. Oh, that is so dirty. Oh, my goodness. I think these little coils right here are awesome, man. I mean, literally freaking cool. There's so much attraction going on here with the N52 little magnets in here in the soft iron cores that, you know, you got to really put some oomph in there to just get it to move, right? But this thing went like 3,000 RPMs with those coils. And it's literally just 2 layers of 20 gauge wrapped around those soft iron cores. I think the torque is impressionable, man. It's a pretty good motor. But this coil that I, just made, I do have a 32 gauge strand in here. Well, there's 10 32 gauge strands. I'm going to hook them up. So another 160 feet of 32 gauge. Now that I think about it, I didn't need to cut the 32 gauge strands, but I did. So that's going to just add the work that I got to do. I needed to cut the 20 gauge ones, but not the 32 gauge ones. Hindsight, if I make another coil like this, I will leave that one intact, because 160 feet of 32 gauge isn't going to generate me much electricity. Not at all. I mean, this one right here generates a bunch, but it's 18,000 turns. Literally, like 18K. So yeah, I gotta talk to chat. I gotta eat here pretty soon. I gotta eat pretty soon. I might be coming back later on. Uh, yeah, everybody, you're welcome. Please come through. We'll be setting up that 32 gauge strand for generator purposes, maybe brake purposes. I don't know yet, but we'll find out. All right. Well, thank you. Uh, really appreciate you guys. Bye now.